Okay, today we're going to be doing some learning about electrochemistry. And electrochemistry is the process of changing chemical energy into electrical energy and electrical energy back into chemical energy. So there's a few vocab words that we need to get through first. The first vocab word is oxidation. Oxidation is when a chemical species loses electrons and the charge becomes more positive. Okay, so the electrons are negative, so it's losing these electrons and therefore the species becomes more positive. Reduction is the opposite. Reduction is when a species gains electrons and the charge becomes more negative. And then we have some more vocab words down here. An oxidizing agent, and what an oxidizing agent is, it's an agent of oxidation. So that means it causes oxidation. So it's a species that causes oxidation, however, itself is not oxidized. So it causes oxidation, but itself undergoes reduction. And a reducing agent is the opposite. The reducing agent is something that causes reduction, but itself undergoes oxidation. So if we think about this, if an oxidizing agent causes something to lose electrons, it itself must gain electrons. So it gains electrons, therefore causes something else to lose electrons. So what we have here is we have an equation of Cu2 plus added to zinc solid, and it makes Cu solid and zinc 2 plus. So what we see here is this process right here of going from Cu2 plus to Cu solid. So it's at Cu2 plus, and then it gains 2 electrons in order to become Cu solid. So it gains 2 electrons, and it is before it's very, very positive, and now it's neutral. So it's become more negative. Okay, it went from 2 plus to a neutral molecule or a neutral species. So Cu2 plus gains 2 electrons, and since it gains 2 electrons, this process is called reduction. Now Zn or zinc solid loses 2 electrons and becomes zinc 2 plus. Since it loses 2 electrons, this is oxidation. Okay? Now, where did those 2 electrons go? Well, of course, they went into copper. So, or in other words, Cu. So what this is, even though this one undergoes reduction, this is what we call our oxidation or oxidizing agent. So this is what caused oxidation of zinc. So this is our oxidizing agent. Oxidizing agent. And this zinc here, zinc lost 2 electrons and it gave those 2 electrons to here, and therefore this is our reducing agent. So zinc right here is our reducing agent. Now this is getting a little bit confusing, as we see here. So even though zinc undergoes oxidation, zinc is a reducing agent. Copper undergoes reduction, but it's a oxidizing agent. So the oxidizing agent is reduced, and the reducing agent is oxidized. And that can get a little bit confusing, and thankfully we have a bit of a way to remember it. So what we have here is Leo the lion says grr. So if Leo says grr at you or gets mad at you, then you should take your oar from your boat and hit him. So Leo the lion says grr, you take your oar and you hit Leo the lion. So what does this mean? Why do we remember Leo the lion says grr and you take your oar and hit him? It's because losing electrons is oxidation, and gaining electrons is reduction. Okay, so losing electrons is oxidation, gaining electrons is reduction. Leo the lion says grr. Okay, losing electrons oxidation, gaining electrons is reduction. And as I see here, Mr. Lum made a spelling mistake. Electrons. Okay. Anyways, now ore. Now what does that mean? Ore is oxidizing agents are reduced. Okay, so losing electrons is oxidation, gaining electrons reduction. Oxidizing agents are reduced, and I don't know how to fit this into our storyline, but reducing agents are oxidized. Anyways, so Leo says grr, you take your oar and hit him. Okay, then that's how you memorize what is oxidation, what is reduction, and what is your oxidizing agent. And what happens to your oxidizing agent? Your oxidizing agent is reduced. Your reducing agent is oxidized. So please remember that. Now, so let's use our acronym to figure this one out again. So this one is losing electrons, and therefore it is Leo. It is losing electrons, and therefore it is oxidized. Okay, or in other words, oxidation. And this one is gaining electrons. Gaining electrons, and it is being reduced, it is reduction. And of course, let's do our last one here of ore. Oxidizing agent is reduced, so this one is being reduced, and therefore it is our oxidizing agent. Okay, and it is being reduced. And this one is our reducing agent, and it is being oxidized. Okay, so Leo the lion says grr, you take your oar and hit him. Okay, now let's do one more vocab word, and then we'll move on to what it means. So redox reaction, and this is just a easy way of saying reduction, oxidation, reaction. So again, we have a slightly different formula here of Pb2 plus Mg solid, or lead ion plus magnesium solid, making lead solid and magnesium ion. So again, Pb2 plus and MgS, or Mg solid. So this is losing electrons, and therefore it is oxidation. Leo, losing electrons, oxidation. Okay, and this one is gaining electrons. It gains 2 electrons, and therefore this is reduction. Okay. Now, our oxidizing agent is reduced, and therefore this is the reduced one, so this is our oxidizing agent. So this is oxidizing agent, and this makes our ROA, or RAO, is reducing agent, and this is oxidized. So let's take a look at some of the half reactions that are going on here. So let's look at the half reaction of lead here. So lead, or Pb, Pb2+, is gaining electrons. So it gains how many electrons? It gains 2 electrons. And it gains 2 electrons and makes Pb solid. And oxidation is, well, it is losing electrons. So we have magnesium solid, and it is losing 2 electrons to make magnesium ions and 2 electrons. Okay, so this is our this redox reaction right here can be broken up into 2 half reactions. The reduction half reaction and the oxidation half reaction. Okay, so here is the reduction half reaction, and where again reduction is gaining electrons and oxidation is losing electrons. So let's take a quick look at some of these gaining and losing electrons and how we can calculate what is called oxidation numbers. Now, an oxidation number is a fictional number. It is the charge of an atom if the species that has the atoms were made of ions. So it's kind of a fictional number where we're pretending everything is an ion and we're finding the charge of that ion. Now, there's a few guidelines that are a little bit loose. Now, the first one is column 1 of your periodic table, or your alkali metals, is usually has a charge of +1. Not always, but usually +1. Our column 2 is usually +2. Our halogens, or our column 17 on our periodic table, is usually -1 ion, and oxygen oxidation number is usually -2. So we're going to follow these guidelines to figure out what are some of the oxidation numbers for things. So here's an easy one that has everything in here. So the total charge of water right here is, well, here, and so our total charge is 0. And we know oxygen, the oxygen has a charge of -2. Okay, and hydrogen has a charge that is +1. Okay, now there are 2 hydrogens, and each one has a charge that is +1. So there's 2 hydrogens, and we add that up to our charge of oxygen, which is -2, and we see that it does equal 0. Okay, so the oxidation number of oxygen here is -2, and the oxidation number of just one of the hydrogens here is a +1. Now, let's take a look at a little bit harder one, which Cr2O7 -2. So we know that this is going to, this whole thing, if you add up all the oxidation numbers here, it has to equal minus 2. Now, the oxidation number of oxygen is minus 2. And we have 7 of those, so we're going to times this by 7. Okay, and we're going to add it to Cr. Now Cr is not in column 1, 2, it's not a halogen, and of course it's not oxygen. So Cr we don't know, and anything we don't know, I like to call it X. And we have 2 of these things. Okay, so if we kind of simplify this just a little bit, we have 2x plus minus 14 equals minus 2. And therefore we would have 2x equals 12 and x equals 6. So the oxidation number of one of these chromiums is plus 6, and the oxidation number of one of these oxygens is minus 2. Okay, now let's take another look at this one, another problem. So again, it has a negative charge right there, so we know that this whole thing is going to equal to -1, and we know that this is oxygen has a charge of minus 2, so it's going to be minus 2, and we know that there are 3 of these, so we times it by 3. Now, we don't know what nitrogen is, so we call it X. So again, we have X plus minus 6 equals minus 1, and we have X equals to 5. Okay, so our oxidation number for nitrogen is 5, and just do a quick, you can do a quick check on your calculation here. So if this was 5, minus 2 times 3 would be minus 6, and 5 minus 6 does equal minus 1. Okay, so oxidation number of nitrogen is this one. Now here's a different problem right here. N3 minus. So what we're going to do is, we know that this whole thing has to equal minus 1 because it's minus sign right here. Now we don't know what the oxidation number of nitrogen is, but we're going to call it X. Now there's 3 of these, and so we're going to call it 3x. So if we simplify this, we get x equals minus 1 over 3. Now this seems a little different to have x equal -1 over 3. Now this is the part where oxidation number is not exactly a true ion number. You cannot be missing 1/3 of an electron. Okay, but oxidation numbers aren't exactly the same as ion numbers. Okay, and what this kind of means also is that when 3 nitrogens have combined together, between those 3 nitrogens, it is missing a total of 1, or has an additional of 1 electron. But what I'm trying to say is the oxidation number is a little bit different than an ion number, and it is completely fine to have a fraction for your oxidation numbers. Okay, now we're going to look at changes in oxidation numbers. And so whenever you have an atom's oxidation number increase, it is being oxidized. So let's calculate the oxidation number of Fe2+. So we don't know the oxidation of Fe, So we just call it X, and well, this whole thing has to equal 2 plus, or plus 2. So we know that Fe2 plus has an oxidation number of plus 2. And same thing with this. We know that the oxidation number of Fe3 plus is, well, plus 3. Okay, so this, as this went, the change in the oxidation number went from plus 2 to plus 3. So it went up, it went up 1. Okay, so it increased 1. That was the change in the oxidation number, went up 1. Okay, so since it increased, it was oxidized. Okay, and that makes sense too. We have Fe2 plus, it lost 1 electron right here, and as we know, losing electrons is oxidation. Okay, so it lost 1 electron, and therefore it has been oxidized. Okay, or in other words, the oxidation number increased by 1. Now, the next one right here, we have when an atom's oxidation number decreases, it is being reduced. So let's figure this one out right here. So again, we have Mn3 plus, the oxidation number right here is plus 3, and we're going to calculate Mn right here. So we see oxygen is usually minus 2, and that's going to be times by 4. So times by 4, that's going to be minus 8, and that's going to equal minus 1. And this is going to be added to, well, Mn is X on this one. So X plus minus 8. So how does that have to be? It has to be plus 7. So Mn right here is plus 7. Okay. Now the oxidation number of this one has to equal 0, and we have 2x equals 0, so the oxidation number of this one is 0. And it's completely fine to have an oxidation number of 0. Now the oxidation number of this one, as we calculated before, is, one of them is minus 2. Okay, so as this one goes from here to this direction, it's going from 0 to minus 2. What we see is that it has decreased, so oxygen is being the oxygen oxidation number is decreasing, and therefore it is being reduced, and manganese oxidation number is increasing, and therefore it is being oxidized. Okay. Now let's take a quick look at this problem right here. We have Na, which is it's a column 1, and so therefore it has an oxidation number of plus 1. O, which is oxidation number of minus 2, and H, which is oxidation of plus 1. And if you add all these up together, it equals 0, and that's what it is here. Now, if we look at this Na, well, this is going to be plus 1, this is going to be minus 1. This is going to be a plus 1 over here, and this is going to be a minus 1 here, and it's equal to 0. This is going to be a minus 2, and again, this is going to be a plus 1, and it's 2 of these, so it's 2 times this plus 1, and that's going to also equal 0. Now let's look at the change in oxidation number. Na, the change for Na, well, it started off at plus 1, and well, it finishes at plus 1. So the change is 0. Okay? And so for oxygen as well, starts off at minus 2, and as it changes, it doesn't change, so the change is 0. And Cl, it starts off at minus 1, and the change starts off as minus 1, and finishes at minus 1, and the change again is 0. So nothing changed. So what does that mean? That means this is not a redox reaction. Okay? And some of them aren't redox reactions. This is a base and an acid making water and a salt. This is not a redox reaction. Okay? This one up here is a redox reaction. This one up here is a half reaction. So half reaction, redox reaction, and this one down here is not a redox reaction at all. Okay?